the work function of very pure Na is 2.75 electron volt. So 2.75 electron volts is the minimum energy that is required to overcome in order for the electron to actually leave the surface, right? So that's the work function. Now we need to compute the maximum kinetic energy of photoelectrons emitted from Na exposed to a wavelength of 200 nanometers. So in order to find out the kinetic energy, we need to first compute the energy associated with this particular wavelength. And out of that amount of energy that is given by this wavelength or related to the wavelength, 2.75 electron volt is required to overcome the forces of attraction, right? So once you subtract 2.75 electron volts from the energy associated with this wavelength, the remaining energy is what will be the kinetic energy of the photoelectrons, right? So the maximum kinetic energy would be hc by lambda minus the work function. Now we can compute the values. 200 times 10 to the negative power negative 9 meters minus 2.75 electron volts multiplied by 1 electron volt is 1.602 into 10 to the negative 19 joule per electron volt. So I'm going to convert everything into joules so it's easier to perform the subtraction. So I'm going to bring (2.75) into 1.62. So this is going to be 9.9 times 10 to the negative 48 joule minus, sorry, this is not going to be 48. That's going to be negative 90. My bad. Okay, that minus 2.75 times 1.602 is going to be 4.4055 times 10 to the negative 19 joules. So if we subtract this value, it's going to be approximately 5.5 times 10 to the negative 19 joules, which is also equal to joule per electron volt. So that would be 3.43 electron volt. Now let's move on to 1.4b. So we're supposed to calculate the longest wave function that will cause the photoelectric effect in pure Na. So the longest wave function means the minimum energy required to cause photoelectric effect. So we need to find out what is the minimum energy required to cause the photoelectric effect. So in order to observe photoelectric effect, the electrons have to overcome the work function, right? So the minimum energy that is required would be the energy corresponding to work function. So the corresponding wavelength is what we need to identify. So the maximum wavelength or the longest wavelength would be 8c divided by the work function. And we know that the work function is 2.75 electron volt, where 1 electron volt is equal to 1.602 into 10 to the negative 19 joule. Now, if I multiply 6.6 times 3 and divide it by 2.75 and then 1.602, I end up with 4.494 times. Now let me bring together the powers of 10 together. It'll give me -7 meter, right? The joule and the joule gets cancelled. The second, inverse second gets cancelled, and the meter. Now, 10 to the -7 meters is not really a great unit, so let's convert it into nanometers. That would be 449, approximately 449 nanometers or 450 nanometers. So that would be the longest wavelength that is required to cause photoelectric effect. Now let's move on to part C. The work function of sodium that has not been very carefully purified. Let's call this impure Na. The work function of impure Na is substantially less than 2.75 electrons, which is the work function of pure Na. Now the question is, when impure Na is exposed to 200 nanometer radiation, will the maximum kinetic energy be less than or greater than that of that for pure Na exposed to 200 nanometer wavelength radiation? So let's look at the Tmax, the maximum kinetic energy, that is equal to maximum kinetic energy would be equal to the energy it would be equal to the energy that is given, energy of the radiation minus the work function, right? So if the work function, if the energy remains the same, with the energy of the given wavelength remaining the same for both pure and impure Na, I'm going to call it pure, we can write the same thing, Tmax impure. This is the same thing in both the cases, right? So when the E lambda is the same for both of them, we know that phi impure Na is much less than phi pure Na. So you're basically subtracting a smaller amount from E lambda for impure Na, which means your Tmax for impure Na is going to be higher than the Tmax for pure Na, right? So obviously the answer would be the Tmax impure would be greater than Tmax pure.